and we are focusing on statistical statistics. Woo, that is a tongue twister. But if we take that back to some of our earlier discussions, we will think about the connection between probability and statistical significance. So, probability is what's the likelihood that something's going to happen. And then if we move from there and connect that to statistical significance, we want to say, okay, and so is that likelihood significant enough that we can conclude that it's not by chance? And that's essentially what statistical significance does. It looks at the differences between two or more groups and identifies that the differences between the two groups isn't by chance. And so that increases the evidence that we have to reject the null hypothesis. But it doesn't stop there. It's important for us to have more than just things are statistically significant. We also want to know, are they meaningful? Within the context of what we're studying, is there enough significance there to warrant us doing more, going to the next step? And that's extremely important for researchers in any field. When we look at the data that we have and look at that level of significance, do we make decisions? Is it for more research? Do we need more research to be set up in any way to help draw more conclusions? Or are we even at a place that we can use this and we have enough statistical significance that we want to create some type of inference that's going to kind of catapult us into the next situation? When it comes to the levels of significance, there are typically two levels, often signified by the lowercase p. One is the zero point zero 0.05 level, which is essentially there is a 0.05, 1 out of 20, or 5% chance that the differences that we're seeing here or what's occurring is not due by chance. So that means that 95% of all the other aspects of what we're measuring that have happened are likely true and not a false positive. The other one is P is either at or less than 0.01, which is 1% essentially chance that differences were found that were not due to the hypothesized reason. Here's a few examples of how that's important. So if we go back for just a moment and talk about probability and statistical significance, in the early stages of COVID, there were two drugs that were looked at in terms of will these drugs, if taken by individuals who've been diagnosed with COVID, reduce the amount of time or shorten the length of time that they experience symptoms. One of them was lopinavir and the other one was remdesivir. Lopinavir, during testing, showed no significant difference. There was nothing statistically significant to say or warrant that that was true. Remdesivir was statistically significant at the p is greater than or sorry equal to or less than the 0.05 level, the larger the percentile population. Why is this important? What that means is different individuals who are in the study of epidemiology or looking at doing vaccines or in healthcare are considering, okay, we might be onto something. So it provided a meaningful enough statistical significance to warrant further research, which may lead us closer to what are the dynamics and pieces and kind of the recipe that we need in order to eventually come up with a vaccine. Essentially, the smaller the p value, the stronger the evidence that we reject the null hypothesis. Statistical analysis is also important not to misinterpret. There were actually some earlier COVID studies that I found fascinating that misinterpreted that individuals who were smokers would be at increased risk for getting COVID and the severity of COVID, to the point that they absolutely had to go back and redo some of the research designs because they realized that leaving out the word statistically significance in a couple of major studies and generalizing it too much made them miss some conclusions of the data. So, as you're going through and you're thinking about what you want to study and what we're looking at, that might be something important for us to keep in mind. Not only are we looking for markers of statistical significance, but why is that important? How does that play into the hypothesis that we're coming up with? And what does that mean for whatever population that we're looking to serve or support by whatever we're going to research?